The next process that we're going to try for solving a system is using the substitution method. So basically, the idea behind the substitution method is to find two quantities that are equal to each other, so you can set them equal to each other and solve for a variable. For instance, what I have here is y equals 3x minus 10, and then I have y equals 5x plus 14. Basically, y is equal to itself. So if I could say y is equal to y, then I could substitute 3x minus 10 in for this y and 5x plus 14 for this y. That's the substitution portion of it, and that would make it so that I am able to solve this like any equation that has one variable by drawing the line down the middle and doing all of the steps that you would do to solve for x. I subtract 14 from both sides. I have negative 24 equals 2x. Divide by 2. X is negative 12. Remember at the beginning of this, I mentioned that the solutions to a system of equations come in the order of ordered pairs. This seems like it should be done because there was so much work involved to get to the point that we're at now, but we really only have the x value. We also need to have the y value. So what we're going to do is we're going to use what we found x to be to find the y. You could use either one of these two equations and plug negative 12 in for x and solve and see what y would be. I'm just going to use the first one, y equals 3x minus 10. For x, I'm substituting negative 12. 3 times negative 12 is negative 36. And if I combine negative 36 with negative 10, I get negative 46. And so now I have the solution to this system. The solution is an x value of negative 12 and a y value of negative 46. Notice that I didn't write this again in an ordered pair. Really, it depends on what medium you're trying to express your answer on. If you had an exam and I was grading it, I would give you full credit as long as you found the value for x and y, which is usually one of the biggest errors that people do is they just stop too early. The next one, find a solution using the substitution method. What I want you to do is I want you to take a moment and pause the video and do this one, and then I'm going to reveal the answer so you can see if you did it correct. Okay, so hopefully you had some success. I found a value of 4 for m, and when I plugged 4 into one of the equations, the output was 1. So the solution for this system is m equals 4 and n equals 1. I also put on these notes a picture, an image that you might see in the calculator. If you were to put two equations in the graphing editor and then you looked at a picture on the graph and you found the intersection. You've probably done this so far if you followed the directions from the first page. But you can also have the ability to look at a table of values. So notice that y1 represents all of the values for the first equation and y2 is all the values for the second equation. If you are ever in a situation where you have to use a table to identify the solution to a system, the solution lies within the place where y1 and y2 have the same output for a given input. In this case, when x is 2, y1 is 0 and y2 is 0. So the solution for this system would be 2, 0. If you were to look at the next example, again, you can see that when x is 4, the output for y1 is 1 and the output for y2 is 1. So the solution to this system would be 4, 1. The next page you have 4 different places, 4 different graphs. We are going to use our abilities to be able to plot points and draw a line for a linear equation. The only thing is, you're not just plotting one linear equation, we're going to do two. So we're going to plot two of them on the same plane and look for their intersection point. If I take a moment and do this first one, the y-intercept is 3. My slope is negative 5/3. I'm going to rise negative 5 and run positive 3. 1, 2, 3, 4, 5, 1, 2, 3. Just because I was limited if I were to try to rise positive 5 but run negative 3. This line is going downhill, which doesn't surprise me because the slope is negative. And then I'm going to go ahead and draw a line to connect the two dots. My best without having a straight edge. And then I'm going to go ahead and graph the second line. This is one of those moments where if you were doing this for a project where it was important to know which line was which, that's when you have to think about making sure that you label the line. Okay, so the next one, the y-intercept is negative 3. Your slope is 1/3, so rise 1, run 3, which I just did. I can also do the 1/3 in the negative direction by rising negative 1 and running negative 3. I am going to draw the line. There's a very clear spot here on the grid lines where they intersect. That's at 3, negative 2. So the solution to this system is 3, negative 2. It happens right here. The second example has a line that is in slope-intercept form, and then it has one of these funny looking lines. Remember, when you have y equals a number, that means we're piercing the y-axis at that number. That happens here. If I were to mark all of the points where y equals negative 1, it would be all of these points here. And the line that I draw is going to be a horizontal line with a 0 slope. Not the best straight line, but there it is. And then the other line that I'm drawing has a y-intercept of 4. I'm going to rise negative 5 and run positive 2. This will create an intersection at 2, negative 1, and that is the solution to this system. I'm looking at number 3. The very first one has a y-intercept of 2, and the slope is negative 2. So I'm just plotting all of the points that I would have if my slope was negative 2. This is for that first line. The second line has an ordered, y-intercept of negative 2, and the slope again is negative 2. The slope is the same slope as the first line, and if it's the same slope and a different y-intercept, this would be the case where you have parallel lines, and when you have parallel lines, that means you have no solution because there's no intersection point. Go ahead and take a moment and do number 4. You can pause the video, and then when you come back, I'll reveal the answer. It'll just take a few minutes. Okay, so the first line had a negative slope, it's downhill. The second line had a positive slope, it's uphill. They intersected at 4, negative 3.